Uh, Good morning. Can I start my presentation?
Okay, good morning, everyone. Please, if you can hear me, just indicate. Thank you. Okay, thank you. Welcome to Sunna Technology Lab Tech Chat, which is a monthly uh, program aimed at. Okay, the aim of the program is to create awareness and to invite tech experts so that they will come and share their experience. Today, our speaker is Engineer Faisal Sani Bala from E-Agri-Science Lab, University of Manchester, United Kingdom. He is a lecturer uh, from Abubakar Tafawa University, Bauchi. He will be talking on improving Nigerian micro, small, and medium enterprises, improving Nigerian micro, small, medium enterprises through embedded systems in local equipment design. Inshallah, he will start now. Due to his on tight schedule, we are going to start. Sir, you can start. Thank you.
Thank you very much for the introduction.
You're welcome, sir. You can start because we know
Okay.
your tight schedule. Yes.
No worries.
Mm.
Okay. Good morning, everyone. Can you hear me,
Good
please?
morning.
Okay.
Good morning, sir. We can hear you loud and clear.
Thank you. Is my presentation slide visible on your screens?
Yes.
Okay, fantastic. Thank you so much for giving me this opportunity to come and share the bit of my experience together with this audience, which has a very good mix of people from different walks of life. We've got people from academics joining this webinar. We've got engineers, we've got entrepreneurs, we've got students. So thank you all for giving me the podium to speak to you all. First and foremost, I'm not an expert in the field. I'm still a student. As such, I'm still learning in the laboratories. So what I'm going to share with you isn't an expert opinion. Most of the opinions are things which I thought I should validate by sharing it with people. And when I have a feedback, then that is when I can work on it to become an expert opinion. Looking at Nigeria, Nigeria is on a trajectory to becoming a great nation. And we've been on such trajectory for quite a long time. Nonetheless, development is still eluding us. And even when we think we are there, we still find ourselves as if we are just moving in cycles. And one of the major things bedeviling this country is our inability to be able to harness from the natural resources which God has given to us at zero cost, at no charge. These natural resources, if we continue to handle them the way we are doing at the moment, then the impact will not be there. and the development will not happen. So I will start first by looking at the major contributors of raw materials which are being used by micro, small, and medium enterprises to manufacture or to sell or to engage in any kind of legitimate transactions to create value and then come have returns. So these two primary sectors in Nigeria are agriculture and mining. You can say out of the 36 states in Nigeria, you can have more than 20 states where there is active mining activity. While you can say in terms of agriculture, there is no single state in the whole of 36 states in Nigeria where there is no arable land or people producing agricultural produce. Or that is to say, these two major primary resources are all over the country, and we have them in common. Why did I bring up this issue? I'm bringing it up because we are talking about processing, and then raw materials need to come from somewhere. It's either raw materials themselves are synthetic for a secondary production, or they need to come from a primary source. These raw materials can be imported into the country, and we can also source the raw materials locally. So the scope of the discussion is going to be narrowed down to two categories of the micro, scale, and medium enterprises. Those that are into manufacturing and processing. So other ventures that are into like marketing and related activities are not going to be covered in my presentation. So what I mean by manufacturing is the process whereby some raw materials, either in the form of primary goods, get into some processes where they get converted into some finished goods, which can be used as an end product, or they can be subjected to further processing. The same thing equally applies to processors. However, the bit of distinction here, which I'm putting, is when I talk about um, processors, some of the processors here do not necessarily involve manufacturing processes. I mean, do not necessarily involve manufacturing. Some of the processors here would simply translate into simple things like drying, like collecting things, like cleaning. So that I don't consider it to be manufacturing. But when we have, let's say, for instance, mangoes collected and then extracted, juice being extracted out of mangoes and packaged, so that I will call it manufacturing. Is my distinction clear?
Yes, it's very clear.
Okay, thank you. So based on the previous slide, I've put down some some um, some industries which are typical, and you find these industries being supported by the government at various places. Most of us have known industrial layouts in our states where they exist, and we've also known about technology incubation centers. So when you go to any industrial layout, let's say you go to Sharada in Kano, or you go to the industrial layout in Bauchi, or you go to the industrial layout in Gombe, so it's highly likely you will come across one of these industries, or you can also find them scattered around in some states. You would highly likely come across a food processing industry. You would come across a local oil mill manufacture, like local oil mill plant. You would come across a local maize flour mill plant, and you may also come across a local rice manufacturing plant, especially after the rice revolution of the previous government of General Muhammad Buhari. You would also come across some companies, some manufacturers that manufacture household products or items. such as soap, such as shampoo, such as detergents. You'd also see others engaging in processing of minerals, such as kaolin, into paints and other derivatives. You would also find some that are engaged in the processing of tin, granite, and their likes. And lastly, you would find where some manufacturers are in the business of making feed for animals. That's farm animals like poultry, like ruminants, and also fish feed. Because I've not come across animal feed manufacturers that manufacture feed for animals such as dogs. So basically, I'm putting these two examples to capture the majority of what I have come across. So these are manufacturing processes. And the thing is, these processes have a common denominator. They have, they have, there are things that happen in these manufacturing companies, which if you go across, you will find them quite common. And what's that common thing? It's called processing. It's called quality control. It's called it's called quality control, or it's called in a more general way quality control of processing activity. So, for instance, if you look at baking, baking is in so many stages, especially when you try to move from bugunkato. Some of you, it's going to sound familiar to them when they say bugunkato. Bugunkato means the kind of bread baking whereby the dough will be mashed upon by some hefty strong men, and then it gets cut into pieces. Then the baking happens when huge logs of wood get ignited and then burn at a very high temperature inside a clay built oven. Then when it gets that hot, then they put in the bread, and after sometimes they bring it out. So we've gone up eating this kind of bread called bungato, although not quite hygienic, but we've survived and we are still waxing stronger. So that's bungato. Then other kinds of food processing, things like processing of soybeans. So you find, for instance, soybeans being processed into different kind of process in different kind of products. You find soybeans powder is very common now for people that have diabetes. You find soybeans milk. You find even the tofu, that's our. So you do find it now in package forms, frozen, and it's been sold to be finally made into any kind of dish by the final customer who buys it. So the process of making bread or bugungato involves temperature. You need to control temperature. You need to control consistency. So consistency and is what you control when you are making the dough. Consistency and then weight. You need to control the weight also. While at the final stage, you control the temperature for the baking. If you come to making things like I've mentioned, food processing, maybe things like awara, or let's say, okay, we can talk about even the powder coming from soybeans. So for the soybeans powder, you also need to look at other things like weight. If you are dealing with it, you need to look at things like moisture content. You need to look at things like um, um, purity and contamination as well. So we also have the oil mill. When you have oil mills, some oil mills just rely on what we call um, hard pressing. So if oil is hard pressed from any source, let's say from granite or from soybeans, and then packaged, it's been considered to be a crude oil. So that kind of oil definitely has no fortification, and the oil also has no color control. So you find the color not to be quite pleasant because of the presence of some constituents that have manifested from the original stock from which the oil is being made. But if you want to make the oil to look better, then you need to do some further processes like the filtration process, like the heating process or the distillation process. So these are processes that have to do with temperature. You need to know the right temperature to heat the oil, because if you heat it at the wrong temperature, you're going to burn it. You might lose the aroma and some other properties of the oil that are desirable by the user. So the same thing when it comes to rice processing. You find quite a lot of rice processing plants, but we always prefer to eat foreign rice, even if it is more expensive when compared to our locally produced rice, despite the locally produced rice having a superior flavor. There are two things to that. The first thing is the the quality, especially when you're talking about parboiled rice. So the quality of our parboiled rice is not at par with what we import or what is being manufactured by, let's say, big industries, which are not part of the scope of this discussion. Big industries such as Olam, such as Dangote, such as Meat Martin. So those industries, they have state-of-the-art machineries, and their processes have been very much optimized. So they are not part of our scope. So when you look at rice produced by our local millers, today the rice will look light brown. When you come next tomorrow, it's going to look dark brown. And then when you come next tomorrow, it's going to look even darker. So there is no exact constituents, consistent. There isn't quite an exact way which the rice will be looking like. So you can't differentiate it in the market. Today you bring something else, and then tomorrow it becomes something else. This boils down to our processes. It boils down to us having control over the processes. The parboiling, the moisture. When you talk about the moisture content of your rice before you do the parboiling, you need to have a threshold, and then you need to maintain that threshold throughout your processing. When you come to the heating, you need to have a specific temperature whereby you heat that rice, and then that temperature needs to be attained and should not go above by some certain tolerance. So that's like rice processing. When you talk about soap, when people make soap today, you can buy it. It works fine. It works like Dudu Osun. It makes you black. Tomorrow, when you buy it, it's going to behave like Cabo White. It's going to make you white. So that's like a kind of inconsistency. And what happens? The problem is in the process of making the soap, there are like chemical reactions that take place. And these chemical reactions, the chemicals being used, they don't come in a consistent concentration all the time, especially when you source them from different buyers. So this chemical, which you use today from, let's say, supplier number one, has this concentration of chemicals, has this, let's say, gram per mole of the active ingredient, and then buying it from another buyer, another supplier, he has diluted the chemical. So when you have a fixed formula of making the soap, it means your soap is going to be having different kinds of consistency. It's going to be having different kind of let's say pH. So when you have a situation like this, then you will begin to lose your clients. And the problem is not entirely yours. It's coming from the supplier that supplies you. But how can you work better to be able to solve it, to be able to make your product to be consistent? Well, that's why we're having this discussion today. The same thing applies to detergents. On the other hand, you have the same thing applying to kaolin processing when you want to make your paint. So you have to look at the paint viscosity, you need to look at the paint color, you need to look at percentage of liquid. I mean, yeah, the concentration of the chemicals you are working with, as well as the consistency in terms of water content in your paint. So these things are to be measured, and then they have a lot of impact. I mean, they have substantial impact on the final product. Finally, let's look at animal feeds. When you have uh, when you have an investment in agriculture, especially when you are into animal production, the major input in your business is feed. If you don't get feed right, you'll never get your animals to give you the right result. Be it in terms of eggs, if you are dealing with let's say egg laying birds. So what you are expecting, you won't get it if you don't give them the right food or the right amount of food. The same thing goes to, let's say, fattening cows or or growing up broilers or fish or fish farming. Here, you also need to have the right feed. And then how do you get the right quality of feed? It needs to come from a manufacturer who has control over moisture content of the grains he's working with, who has control over the weight of methionine, which is putting into the feed, somebody that has control over the weight, final amount of kg he's selling to you. Let it be consistent. It's quite unfair when I buy like 5 kilogram of feed today, and then the feed is having like it's having a deficit of close to, let's say, 500 grams. So if this happens consistently for 2 months, then it means I'm underfeeding my animals. I'm using less amount of input for my business, and definitely this is going to be an issue that will manifest in the final output. So I believe you can look at other situations whereby quality control comes under scrutiny, whereby quality control becomes a problem and it manifests in the final produce, which an MSME is selling to the consumers. I believe there are quite many of them. If you like, you can send in an example in the comment section. I can get to the comment section and look at it, or you can, yeah, you can just put a thumbs up if you've understand what I've been explaining in the slide. So let's go to the next slide. So in the next slide, I am this question. Okay, what does improvement translates to when we talk about improving the Nigerian MSMEs through adoption of embedded systems? So what does improvement translates to? Here we have, there are two sides to the coin. We have the client side or the customer side, and we have the manufacturer side or the business side. Um, I have erroneously or mistakenly forgotten the third player here. That's the government. Okay, so the government also plays quite a good role as a regulator and as a tax collector also. So I've not put in government here, but I would still mention how quality control, improvement in quality control has to do with government. If I finish my explanation on the two sides of the coin, which I actually couldn't, which I actually forgot to think about the third player, the government, when I was putting down my slides. So from a customer's perspective, from a customer's point of view, you would like your rice to be of consistently high quality. You would like it to have the same color. You would like to use the same amount of water to be cooking the rice today. Do you like to use the same amount of kerosene or gas to cook your rice? So you wouldn't like your rice today to behave like gari when you're cooking it. It melts so fast. And then tomorrow you wouldn't like it to behave like beans. So that doesn't all go well with the customer. So that consistency in quality is very important. The same thing, you wouldn't like to test my yogurt today. Let's give a fictitious name to a yogurt company. It's I'm not marketing any company. Let's just give it a name. Let's say Amal Yogurt. So you wouldn't like Amal Yogurt today to test sour and watery, and tomorrow the same yogurt testing sweet and then consistent with all the flavor. So we wouldn't like that fluctuation. However, the person making amal yogurt needs to contend with his source of raw materials. But to you, that's not your problem. All you need to have is amal yogurt to be that refreshing, to be that nice, to be that thick and delicious all day, all year round. You also like to have it on the time. You need to make it available, and then you need to have it in a stable price. So availability and stability of price, there are factors. Some of the factors which are relevant to my discussion is storage. When you store raw materials, the storage does not happen in, I mean, you just don't store them without conditioning. So to store them, you need to condition them, and then to use them after storage, they need to be conditioned. So how they are being stored and how they are being used after the storage will affect the quality. And it's now entirely your business to make sure your stored raw material is as good as the freshly sourced raw material, even though it can't possibly happen that way. But you need to try to see that it's almost like that. So stability of price also depends on the storage, and then depends on what you are putting out to people. If you are putting out good produce to people, of course they can buy it at a good price. But when you put out a good produce today, a bad one tomorrow, then the price becomes quite unstable, because customers might decide to make their own consumer behavior to be the judge of, to be the judge, and then to use that to at which they would like to buy your produce or not. Then what about the manufacturer or the business owner? How does improvement in quality affect him, or what does improvement in quality means to him? So to a manufacturer, an improvement in quality can translate into many things. One of those things is reduced manufacturing energy, especially reduced manufacturing cost. So reduced manufacturing cost, especially in terms of energy and labor. So these two things are inputs that are very, very important to the manufacturers. If you spend a lot on energy, your business, your cash flow might go negative. If you spend a lot on labor, your cash flow might go negative. So reduced cost of manufacturing would mean you minimize energy and then you minimize labor. So I beg your pardon for the typographical error on my slide here. It's a slide that was hastily put together. So looking at reduced cost of energy and reduced cost of labor, let's take a simple case study. Look at the case of having um, making bread. So assuming I'm not using lots of food, because where I'm living already we've started to reap what we've sown. We've started to enjoy this hot, scorching, dry season sun, something that we've not been seeing before, but we have to live with it as we've cut down most of our trees. So when I live in such kind of region, now it's almost an absolute necessity that my company has to be buying gas to make bread, because local food is becoming quite expensive. But if I buy gas to make bread, the kind of local equipment manufacturer that supplies me with with oven, his kind of oven is not smart. His kind of oven would just burn the gas at an arbitrary temperature. So now it's left for me to be sitting by the side of the oven to be regulating the gas, and which is quite time consuming. And I cannot be able to do that for all the hours of my operation. So it's either I put out, it's either I ignite all the burners in the gas and make my bread, or I need to find another alternative. So when I run my gas for those hours to bake my bread, and I come to reconcile my books at the end of the business day, I would see that I've spent quite a lot. I've spent a lot on gas, and I've also spent quite a lot on quite a lot paying those hefty strongmen to pounce on the bread dough and then make it to have the right consistency, which I need. So it's a time for me to rethink. Despite all this effort, I'm still having problem with quality control. So if I can fix my quality control, the way to fix the quality control will equally address my energy issue, and it should also address it's also going to address my cost of labor. It might sound as if it's the opposite if you look at it from a layman's perspective, but when you look at it from as an expert's perspective, when you fix the quality control, you get these things fixed. How to get these things fixed through quality control is one of the questions we are going to answer in the slides to come. Also, you would have improvement in quality control translating into reduced damage of raw materials. Yeah, you don't have to take a lot of bad produce because you have to do a lot of sorting. You have burnt bread, you have underbaked bread, and then you have the nicely baked one. So you don't have to take out the burnt bread and throw it away, or the underbaked bread to throw it away, simply because you want to maintain your reputation in business. So you don't have to have damage to your raw materials, which is expensive to get. Then issue of safety and hygiene. When you have a lot of all the processes being done manually, so there is issue of safety, there is issue of hygiene. What happens if I say this person should be by the side of the burner to be regulating the heat? Whoever is regulating that heat is going to be susceptible to any kind of occupational hazard that can that can result as a result of exposure to high heat. The same thing when it comes to hygiene. When I have too many people dealing with my yogurt, testing it, putting a strip in and out of it, putting a strip in and out of it to test the acidity. When I have so many people putting in different cups and scooping instruments to test my yogurt consistency, to test the water quality manually, sorry, to test the water content manually, then at the end of the day, hygiene would be compromised, and you would have to deal with the backlash when people buy this yogurt and then begin to suffer from illnesses such as diarrhea. So when you have a control uh, over the quality, then you have control over safety and hygiene as well. And how does this happen? It's still going to be a single question, which we'll be answering later in our presentation. So to make any product, high quality products can be produced when standard production condition and procedure are adhered to. So these production conditions are mostly categorized into, we have so many categories and there are quite a lot of them. But those that are common to the industries I've mentioned are the ones I'm going to talk about here. So we've got temperature, we've got pH, we've got pressure, we've got volume, we've got moisture content, and then we've got weight. When you talk about temperature, I've already mentioned how it affects rice parboiling. I've also mentioned how it affects the refining of cooking oil, and also, though I have not mentioned how it affects tomato paste, but tomato paste also, the production needs a lot of heating. So the heating comes from energy sources, and we need to have control over the energy sources to be able to run a tomato paste production efficiently. But you also like to have it to have a certain quality that is going to be at par with what major or mega manufacturers are having. Although the presentation is all about MSMEs, but we are bringing out these strategies for MSMEs to be able to position their businesses to compete with bigger manufacturers. As MSMEs have always gotten training from different developmental organizations, from different government agencies on how they can market their products, how they can sell to clients, how they can have a structured organization. But nobody comes down to talk about how do they adopt technology, what's the path to adopting technology, and then from where will the technology come, and then how does our local indigenous technology becomes a viable solution when we improve it using some techniques or some methods that will make it to be good and superb. So we have also things like pH that affects tomato, that affects tomato-based production, that affects juice, that affects yogurt. So we have pressure. When you talk about pressure, mostly is when you deal with things that come under compression. For instance, you have any product whereby you would have to do some compression to get it to the right size or quality. So you have to deal with pressure in that case. You also have volume. I wouldn't be happy if I buy your, let's say, bottled water. Your 35 cl today is 28 cl. Tomorrow, your 35 cl is 30 cl. And then it fluctuates again and again. So volume also, being able to understand volume as parameter which you have to put under your control. So whatever I've put on this screen are parameters which you have to put under your control. So if I say control, it means you can be able to increase them, you can be able to decrease them, and you can be able to keep them constant. So any industry that wants to have a high quality product as an MSME, they need to have machines that can keep these things constant if they are to be if they are to be increased to meet the production condition or standard procedure for the production of their product, then it should be within their power to be able to increase it. To decrease it, it should be within their power, and to maintain it should also be within their power. So that is what is required of any locally manufactured machine that is being used by any MSME to manufacture good for the consumers. So the machine should be able to control any of these relevant parameters, which is um, which is being used for the manufacture of products using the machine. So I've mentioned control, but how do you control these things? I said controlling temperature. How do you control temperature? I said controlling moisture content. How do you control moisture content? I've mentioned controlling of weight. How do you control weight? I've mentioned the control of pH in your sub business. How do you control pH? The answer is simple. We have been working with computers knowingly and unknowingly. If you've driven a car before, that car has more than 200 computers in it. If you have a typing glass, the typing glass gets wind down through a computer. When you have your transmission, the automatic transmission is being controlled by a computer. Your accelerator is being controlled by a computer. The the microclimate inside your car, the AC or the heating system is controlled by a computer. The airbag is controlled by a computer. So these are all controlled by computers, but we don't see the computers. So those computers controlling these processes are called embedded systems because they are embedded. They are kept behind the curtain. They are kept under the dashboard of your car, so you don't see these systems. But embedded system, should I continue?
Yes, you can continue.
Okay, thank you. Okay, so the embedded system, as as I've mentioned, is embedded. You don't see it quite. You don't see it most of the time. It's just a computer that is running from the background. So this computer, its capability is that directly it can control your manufacturing. It's very cheap. It's very affordable. It's very easy to develop. It's not as complex as the computer that runs your Excel sheet, whereby you take your records. No, these computers are very, very cheap, but they can improve the quality of what you are doing. They can help you to cut down on your cost for gas. They can help you to cut down on your cost for raw materials. They can help you to reduce damage. How do these computers work? It's not miracle. They are being built, they are being programmed, but the process has become so easy now. So the computers get attached to things which we call sensors. You've been hearing about sensors, a computer having a sensor, your car having a sensor, especially when the mechanic wants to make some money out of you for no reason. So he tells you that the sensor has failed. But how does the sensor fail? He doesn't tell you. So simple sensor that can be able to measure temperature is called a thermocouple. By taking thermocouples and including temperature control in, let's say, 200 MSMEs in Nigeria, is going to translate into a substantial amount of profit for those companies. It's going to translate into a substantial amount of quality control and improvement in their produce by just having a simple thermocouple and a simple embedded systems computer or a simple embedded computer that controls the temperature. These devices, you can find them off shelf. You can find them, they can be built. They are like customly built devices. So they are quite common to get. So the same thing happens to the rice milling. So your rice milling business would improve if you take some little investment and put it into using the right technology to upgrade your machines. So how about now not just upgrading the machines? How about the local machine manufacturers themselves coming together with people that work on embedded systems to make this machine smart from the beginning. I believe it's something the Taiwanese, the Vietnamese have been doing. It's the same thing those people in Thailand have been doing. And it's the same thing those people in China have been doing. So we may not need to import all our machines from China. We may need to import some parts that we can use to build our machines here in Nigeria. And we have the people with the right brain, we have the people with the right training that can undertake such kind of task and then get the result. So these machine manufacturers coming together with embedded systems designers will give us the machines that we need in Nigeria to solve our problems of converting primary goods into high quality goods that can be able to compete with goods coming from major manufacturers or goods that are coming from import. And why are we making all this noise about MSMEs? These MSMEs provide a lot of job opportunities for people. They are very easy to locate, they are very easy to establish. And then when it comes to regulation, the government has relaxed regulation when it comes to dealing with MSMEs as it has as compared to the kind of regulations when it is dealing with huge manufacturing costs. So when you have computers, you have processing plant for tomatoes, you have a processing plant for oil, and then you now know how it looks like. At least you've had the word. You need a thermocouple to regulate your heating, to regulate your gas. You need a pH sensor to regulate the chemicals you are using for your stock production. You need to have a stirrer, and your stirrer needs to have some certain whatever that is mixing. Your mixer needs to have a certain speed at which you need to maintain it to have a consistency, not your soap to be having a different consistency for each bar of soap that comes out from your industry. So now we have an idea of how embedded systems can help us to achieve that. The next question is, are embedded systems cheap to develop? Okay. If I am making this presentation in the 60s or 70s or early 80s, this question might be a no. Why? Because those days we have very expensive hardwares that make up what we call the embedded systems. So we've had systems for those of us coming from a technical background. We've had expensive hardwares like the Intel series, the 80 series, 8080 series, 80x86 series, 8085 series. So those are very expensive hardwares that that are difficult to develop for many reasons. First thing, you find very few people are talented enough to learn how to design with those machines, to learn how to upgrade their softwares, and then to learn how to maintain those machines. So that has been out of the question. So the thing has changed, and now we have is technology has evolved so much. So now embedded microcontrollers are cheap. There are new technologies that are being used to do the design. There are new software development tools, and then the way the silicon real estate is evolving, it's crashing the prices of microcontrollers and anything electronic. When you compare the price, before it takes quite an onerous effort to find a single house with a television set in the 70s. Why? Because it's expensive. But now in a single house, you'll find 5 to 6 television sets. And these television sets, because now are running on simpler or cheaper embedded systems, simpler or cheaper display systems, all put together. So the same thing now should translate into our industry. We shouldn't be driving state-of-the-art cars, having access to the best home luxuries at home. But when we go to manufacture goods and services, we are still stuck to methods of producing cheaper goods that have been used before the industrial revolution. So we need to take a jump, we need to take a huge leap, and then get ourselves into the 21st century. So let these machines which we are producing be of high quality. We can do it locally. We have the capacity, we have the engineers that can do that. So my next question, I've mentioned industry before, I've mentioned clients, but I did not mention government. And there is also another player, university. I did not mention university. Here also, I've made a mistake. I shouldn't just say a university. I should have addressed tertiary institutions in general. So that is what we call the triple helix innovation model. Triple helix means the university, industry, and the government need to work in tandem to be able to provide solution to the problems that are bedeviling the society, to be able to provide solutions that will meet market gaps, solutions that can drive economic growth, solutions that can provide import substitution, solutions that can provide goods and products that can be exported. This model was developed by people that live thousands of miles away from us in Nigeria, and it's developed to help them. But when you look at the model very well, I had the feeling, because I've not scientifically proved it and I've not taken any time to do some extensive research to prove it wrong, but I have some reservations about the model. So especially now that we are in a bit of a different kind of era, whereby we have this notion of co-learning, we have these new players coming into play, and now when we say new players coming into play here, we have university, we have industry, we have government. So currently I'm working in the university, but it's not a university that gave me the podium to talk about MSMEs. Another player gave me the podium to talk about MSMEs. That's innovation hubs. So now we have innovation hubs coming in to be problem solvers in our society, in our communities, and they are not in this model, which we call the triple helix model. So we can't find a place for them as far as this model is concerned. But they are becoming strong and they are exerting quite a lot of influence in the community, and they are becoming like a force to reckon with. People need to work with them. So we don't have them in this model. We have innovation hubs now. Then we have another player. Those are the artisans and local fabricators. So here we just have an industry, and then the definition of the industry here does not properly fit into description of MSMEs, and these local machine fabricators are not in the context. So we need to have an indigenous and organically developed model for our innovation that works well for us. So instead of taking the triple helix model or investing too much energy or effort, maybe we might come up with our own model. If we like, we might not call it triple helix model. If we like, we can even give it some local name. Maybe it might even be Zogale model or anything. Yeah, but let it just be a solution organically developed by us and for us. So for this presentation, I had to think. And since the presentation is not just about me presenting, but about getting feedback and learning from my audience. So what if we have a new model that takes into account, that factors in these new players? We have innovation hubs now becoming more and more influential, and their numbers are building up, which is something that we have to be very, very happy, since we are in an era whereby funding of education is very difficult. To fund education, to fund infrastructure that can support education is a heavyweight thing. But innovation hubs are lightweight solutions, and they can complement academia. They can complement even research institutions. They can even complement the effort of government in research. Come to think of it, when first these innovation hubs started when we first started to see them in the university, some of us actually were thinking like, these are just people coming out to rip off people of their hard-earned money just to help them build final year projects. So these people are just some group of cheats coming together to make students have a workaround, not to do their final projects well. But these innovation hubs have put in some resilience. They've survived. And now their story is that they have become major players, and we need to work with them. We need to work with them in tandem. So universities need to work with innovation hubs. Polytechnics need to work with innovation hubs. Artisans need to work with innovation hubs, and the government, but for different purposes. So the purpose here, it's not about making payment systems to be pervasive, whereby people have access to finances or financial inclusion or whatever. I mean, the kind of things Innovation Hub have been doing in IT. So that is quite a good fit. They've been doing quite well in IT. What about now innovation hubs coming to participate and then getting into the jungle. I mean, getting their foot down into the battlefield, working in the real sector, working with local artisans, pushing the boundaries of local artisans, making machines for MSMEs to help MSMEs to be able to have their goods and products attain a higher level of quality. So I know innovation hubs have helped so much in the past to teach these MSMEs how to do marketing, digital marketing, growth hacks, and whatever. But now we need these innovation hubs to come down and get these things done and then get dirty with the work. So a model of the engagement would involve development of new ideas through hackathons and engagements. Now innovation hubs would have to engage with artisans. For instance, let me put out an example. Let's say in Jos, Sunna Innovation Hub will go to Adebayo Street, will meet with let's say people making milling machines. They would go to, let's say, some of those people making agro processing plants or people making battery cages. They discuss with them and then they go back to check from the other end, how are the people that are using this machine scoping? What's their problem? And then an innovation hub will put out a new hackathon, and they can do it, let's say, in partnership with the university. So this hackathon this year, we've gathered these problems for the university. We think people need this, and that. So we would like to have a hackathon, and then people that will participate in the hackathon will come from the university or from the polytechnic, and then these are the themes or these are the areas which we would like them to work on. So when they work in these areas, they develop some ideas as proofs of concept. So these proofs of concept will now be refined by the university where they have manpower to conduct the research. So they can do the research there, and then universities of course do have access to funding. What I'm not sure is if the kind of funding, the kind of research, the kind of problem which innovation hubs and local artisans will be posed into universities, are they the kind of research, do they meet the kind of benchmark which the government would like before it gives money for funding? Are they the kind of research which the university academics or the polytechnic academics would like? Are they the kind of research palatable to them? Are they researches that can lead to publications in high index journals? Or are these just researches that will make it easy for people to have food on the table, but food of high quality? So these are questions the university, the innovation hubs, and ourselves need to answer, and the government. We need to ask the right question and we need to give the right answer. Finally, I have an isolated player, startups. I have not mentioned startups, but we need to really look at how do startups get into this play? How do startups help with, or how do startups help to manufacture? How do startups help to provide embedded systems technology to artisans and local equipment manufacturers to make their technologies to make their equipment to be better, to make their product to be better? So startups have a very huge role to play, but I haven't mentioned them. But we need to find a way by learning from each other to find the right place to put startups. This brings me to the end of my presentation. Thank you so much for giving me the opportunity, and I am open to any question. And thank you so much. Thank you, and thank you once again.
Okay, thank you so much, sir. Um, it's been great opportunity to learn from you. I believe, please, if we have any question, please you can write them on the comment section. And for MSMEs, they are micro, small, and medium enterprises. While the macro, they have 10 or less than 10 employees, while the small have 49 or 50 or less than that employees, while the medium, they are 50 to 200 employees. So these are the particular set of people our speaker is talking about. And we know this is quite timely because we know a lot of them, they are coming up. If you can uh, include them in this journey and we can provide possible solution, it's going to be a boost to our national economic development. I would like to give some minute to our IoT lead here at Sunna Tech Lab. Is also an embedded system guy, Abdullah Hagos.
Good morning, everyone. I want to use opportunity to thank the speaker for the enormous knowledge shared, and also Suna Tech Lab for organizing this meetup. I also have one question for the speaker, and my question goes like this: how do you what advice do you give someone that has gotten the basics of embedded systems and IoTs and wants to move his products from prototype stage to production ready state? And also, um, what are the necessary skills he would need to improve on before he can embark on such journey? So maybe when you respond to this, I'll ask the other question. Thank you very much.
Mm. Abdallah, thank you for your question. The question you just asked are questions I'm also asking. I mean, it's I'm also involved in such kind of thing, but it's a process really, and it doesn't happen in a day. But you just have to do it. So you have to force yourself to push your first product out of market. Sorry, out of the lab, out of testing. Okay, it's a difficult task. I know that, especially when you can have a prototype working, but when you want to go for mass production, you need to be more careful about that. You just finish designing a product and it works well in your lab. When you take it outside, you will be having lots of challenges, lot of issues to contend with. So the advice is you need to take it incremental. Just that make sure when you start your first product, do not make it to be a product with complex functionality. Why? Because testing is very important. That is what we call the unit testing. So if it has a complex functionality, then the testing becomes very difficult. And then even the manufacture becomes difficult for you, trying to manufacture from the first time a very, very complicated product. So first thing first, whenever you want to build any product, build it as simple as possible. And then take the simplest version and at least develop a prototype. If you have a prototype, then you can work on the first version. Secondly, it's good to work in teams. No matter how good you are, you would always find people that are better than you. You have to know that. For instance, in the university, when we teach, we found out that a substantial amount of the students are extremely brilliant and better than us. So now it's how do you benefit from people that are better than you? Get them in your team if you can. If you cannot get them in your team, reach out to them, seek their expert advice, work with them. So people that are better than you will always give you superior advice or superior contribution. So make sure you have a team and don't work alone. So people that are out there with good skills, you either learn a new skill from them, or you can as well uh, meet up. You can team up with them and then get the work done. So it's just about getting the work done. It's about getting your things right. Reach out to people that you think are experts. I still reach out to people. I still send cold emails to people on LinkedIn if I see they do impressive things. And some of the people I'm sending cold email to and get to start to engage and I learn from them. Some are even undergraduate students, but I get so much impressed with them, with what they do. In fact, some are not even students. Some are, I mean, dropouts, but they have the talent, they have the skills. So I reach out to them and I learn. So, so you can take that as part of your product development, working with people that have expertise in a certain niche that you need for your product. Make sure those people you get the best out of them to improve that part of your product. There are people that are just too good with PCBs. I mean, they can work on 5-layer PCBs. When you see how they bake components on a PCB, how they put paste, soldering paste, how they arrange components, you would just think like these people are pick and place robots. And they just use magnifying glasses and some simple pick and place instruments. But you would think these people are robots. So when you meet those people, don't envy them. Go and tell them, okay, as of now, my PCB knowledge is here, and my product needs the PCB knowledge that goes there. So how can you come in, sir? How can you help me? If you have money to pay, pay. Whenever you have, do not spare, do not be pounds penny wise and pound foolish. If you know you have to pay people for their skills, tell them all that you can offer. They might decide to charge you, they might decide to make it free for you. But make sure you reach out to them and then you try your best to get the best out of them. There are people very good with softwares. So reach out to them. If those people will give you the best solution, sometimes your knowledge is just to build the proof of concept. So having the knowledge to build proof of concept means you can do the initial wiring, you can do the initial PCB, you can put all parts together, and then you present it and it works. But now you need to have a product that will be sold to like thousands of people. So in that case, then you need to optimize each of these processes by reaching out to better people. Then once you have this your design ready, the next challenge is supply chain. I can tell you supply chain is what has crippled a lot of people getting into the startup journey. We faced supply chain problem launching one of our products here in Nigeria like 4 years ago. So it was a time when the dollar made its first astronomical rise. So that actually crippled a lot of things. So those are things you have to look at. But I actually don't have much answer about supply chain. Maybe you would have to work with people that maybe doing a lot of transactions in China and are dependable. Because believe me, your money will get stuck somewhere with someone that will be telling you, then Allah then annabi kai haƙuri. So you have to know that, yeah, you've made supply, you've made contact with the company in China, and then they've sent you 20, 200 LCDs, or they've sent you some bulk boost converters. But getting those things out of China now would be a nightmare. This your friend will tell you he has sent it in ship, he has sent it for sea shipping. Next week she's going to tell you he has sent it for an into an for air flight. So you just wouldn't know what exactly is happening. So there has to be a new way to address this issue. Maybe one of the possible solutions I'm thinking is if we can develop a model of coming together, like syndicating, a syndicate buying. So syndicate buying would mean like 5 innovation hubs, 5 startups would come out and say, okay, these are the components we always need to use. These are the dependable PCB manufacturers which we can think of. So now we would be having like a quarterly way of procurement. So in a quarter, we would put together our BOM, our bill of materials, and then we source for forex together. If we syndicate, we are going to enjoy what we call the economies of scale. So you come together, you syndicate your demands, you put together your whatever, you get it shipped to a single location, maybe in Jos or in Kano, in Kaduna, wherever in Lagos, and then you can dispatch it to the various startups or you can dispatch it to the various innovation hubs. Well, that's what I would say. Maybe there are some people I've missed out, but it's because I don't know them or I might have forgotten.
Thank you so much, sir. Please, we'll give some few minutes to people that are raising their hands. We have Mr. Ezra. Are you there? Mr. Ezra. Okay. Mala Abdul Majid.
Okay, hello.
Yes, we can hear you.
Okay, so good afternoon, everyone. So I'm Abdul Majid Babale. Uh, I want to share some. I want to make some comments based on what our guest speaker has said. And so, first of all, I will make a little intro about myself. I am Abdul Majid Babale, an embedded system engineer too. Myself, I'm a graduate of Bala University, Kano, and I've been in the industry for a few years, maybe 3 to 4 years right now. And as our guest speaker said, I'm actually happy that we get people share things like this because as I can tell you, there's a lack of awareness when it comes to software, especially in our country, Nigeria. Maybe because there are a lot of difficulties you face. But it's good that we have someone like our guest speaker who have experience too, and it's also part of the academy. So as he said earlier, like from experience, what I've seen is that there is no synergy, should I say, no synergy between maybe the tech hubs, the universities, and the artisans. So although the things are trying to get better now, which is very good, but from my experience, I think I have tried working with from the industry innovation iron in an innovation hub where we work on embedded system and a lot of things. I have tried working with those from the industry are open working with them, but from their end, so we face some challenges. So maybe some of their challenges are as you said, embedded system makes things complex and there's cost. So there's a lot of factors when you decide to move from what you are used to. Maybe they are used to producing their machines manually. Then you come and propose like you need to change, put sensors, put this and this. Some of these artisans, not often, some of these artisans, it's not all of them that's really understand the technology behind it. Like, so they'll be like, this is some sort of the uh, as you know, our people, they'll when in Mbokuni, like they they will see us as like we don't have the skills. You understand what I'm trying to say? So it's just like there's this thing that people that study engineering in school don't know anything, something like that. So they'll see like they are superior to us, but we are trying to dictate something to them, something like that. So there are a lot of issues like that. But as you said earlier, if there is this synergy, I think it will be for our industry. So
Okay.
thank
Okay. Thank you for your contribution, Mala Abdul Majid. Then we have Malang Awal. Please, a very quick one. Thank you. Mala Awal. Mala Awal Nasiru. Are you there?
I think maybe he mistakenly just pressed the raise hand
Yes. Okay.
We can't hear you, Mala Ibrahim.
Okay.
I think your mic. Yes.
Okay. Okay. Thank you so much for all the for us to our speaker in particular, engineer. Thank you so much for your time, and thank you for trying to explain this and bring this thing out. And thank you to all the participants. I would like to request Abdul Hafiz to give us a final word. Then we are going to meet next during our next tech chat. Please keep on following us on all our social media handles. Thank you so much. Mala Hafiz.
Assalamu alaikum warahmatullah. Thank you so much, Mala Ibrahim, and thank you, Dr. Engineer Faisal, for your time. Actually, I know your tight schedules, but you honored our invitation. My final word is, as you have rightly said, uh, using the embedded system or bringing it out, we need to work with other organizations like the universities, the artisans, and I look forward for Sunatech Lab to do that in not a shorter time. And thank you so much for coming. Jazakallahu khairan. And thank you for everyone that come. And lastly, this meeting is being recorded. You can find the link on our YouTube channel if you want to listen to the program again. Thank you once again.
Okay. Sir, any final word from you?
Uh, there isn't much to say. I think I've spoken all that I need to. The only thing I would say is we we shut up and get to work. We shut up and get to work. Okay. So that's my mantra. Just we shut up and get to work. Let it not be another follow-up session on this. Let it be a round table discussion of the development we have so far. And
Yes.
as much as possible, you should have a timeline, develop a timeline on how you think your innovation hub can be able to partner to reach out to local equipment manufacturers, have a hackathon, take a case study, develop a hackathon, and how you can be able to liaise with the university. I know it might sound like an onerous task to you reaching out to the university, but you have people that have soft spot for innovation hubs in the universities. People like myself, you can easily reach out to me. We are people that have always been encouraging innovation hubs and working with them, even when it was not welcome in the university some years ago. Okay, so please make that arrangement. And whatever I've said, there are things that are doable. I have little experience of doing them to some extent. I have seen just how a simple thing as a copper made a lot of change. I when I was a copper in 2013, one of my friend has built a very huge feet dryer for a client in Yola. And then the client was he was not having the complete knowledge of how to build the heating system of the dryer. It's a feet dryer. It's a tray-based or a drawer-based feet dryer. And I was just passing by the Center for Industrial Studies at ATBU, and I saw a machine. I knew the machine for quite some long. In fact, right from the days when I was a student from 2004, the machine has been out there. It always gets beaten by the rain. And I just looked back and I saw how they arranged the heaters. But the machine was having just one issue. They have a thermostat. And believe me, thermostat is a technology that predates First World War. Okay. So look at it. It's a machine now developed in let's say 2005, 2006. But what controls the heating is coming from First World War era. So we look at that, look at how we can put a thermocouple, and before you know it, the machine in Yola is working. And even an improvement was made. Instead of using the kind of heating element we saw on that machine, we went for even a more efficient one, which we scavenged from some heaters that are being sold as fairly used heaters for rooms, and it worked. So I've also have a friend, it's what you give him a visit, the technical aid to the managing director of JED at the moment, Engineer Usman Ismail Abdullahi. If you really want some talk, you can talk to him. So we've been friends in the university in Malaysia, and we've been rebels as students actually. So they say they want us to work on drones. We say no, we want to work on Nigerian problems. So that actually made us to develop a different mindset. So Usman makes smart ovens. His smart ovens, you just put a preset and it works fine. It will definitely cut down the cost of how much you would put into to buy gas when you run his oven. So definitely it's going to be something that would be profitable, especially now that we have ladies going into the business of baking. So they need to do it at a cost that is not very expensive. So you can reach out to him. It's one of those things we've been brainstorming and then having solutions. And I've also worked with people that design machines in Technology Incubation Center in Bauchi. Although they are no local artisans, they are experts, but they are like very, very thoroughbred mechanical engineers with a lot of expertise in machine design. And whenever we come together, they bring their own expertise and I bring the little that I know. We share together. We've always made machines that have been different. I think I first pioneered that thing. I first pioneered reaching out to them And after that, I've seen my colleagues from electronics reaching out to them now and then working in synergy. So the good thing is always to start the reaction, okay? Pioneer this thing and then start the reaction. And now everyone is amazed when they bring their expertise, and then electronics, you with your electronics background, bring your expertise. So the kind of things that is being made at the end of the day, they've made like a lot of winning machines. Some of those machines that have come out of that synergy which I created have gotten TED fund grants. I mean, the people having TED fund grants, they didn't even know I started the whole thing. I was the first guy that went there and not decide to do it on my own, but to reach out to experts that are mechanical engineers that are thoroughbred, and then bringing my knowledge and then showing up that to some of my colleagues, and then those my colleagues invited them, and then the process gets going and going. So if we can leverage on such kind of things, then we can do a lot of things. We can do quite a lot. So that's my final word. Always leverage, always try to bring people with new skill sets, meet people with different knowledge sets, and then put what you have together. You would always have a very fantastic solution. Thank you.
Thank you so much, sir.
Yeah,
We really appreciate.
right.
Thank you for your time. Thank you for all the explanation, the effort. Thank you so much, sir.
You're welcome.